Okay. According to the YouTube data coming through, let's just do the usual and make sure there's... Okay. There we go. Beautiful. Audio, video, we're all good. So this is some random Windows-based PLC type thing. It's a 15-inch monitor with some PC on the back, and according to the customer, it works great, except that there are black stripes in the display, and they go away when they do that. So we probably just have some bad connector inside, could be bad caps. At some point someone has replaced a couple of capacitors here, covered it up with a piece of like random packaging plastic. Not my work, but it probably works just fine. So we're gonna just rip this thing apart and see what we find. So for starters, I'm gonna just disconnect the hard drive and try and power it on, see if we can replicate the black stripes. They supposedly come and go every now and then. So some starts it might work just fine, other starts it might not work at all. So it's an intermittent issue, which is always a bit annoying, but there are a few common causes for that kind of behavior, so I'm not too concerned. What I am concerned about is figuring out how to actually get this thing apart. These industrial things always have so many screws. People are showing up in chat. Hello there, Robin Vandenide and Fluffy Floof. Good to see you. This is not going to be a particularly exciting stream, I don't think. It's just a PLC with probably nothing more wrong with it than a dodgy connector. But hey, at least we might get to have a look at powering one of these things up on the bench without having the rest of the machine available. So that's the fans, and that's the IDE ribbon cable for the CD drive. It is a CD drive, no DVD here. This thing does have a label, by the way. It's called Robust Panel PC Pentium 3 Processor 15-inch TFT Open Frame CD-ROM FDD. And then it says it's got a Celeron, not a Pentium 3. And a 2.5-inch 20GB hard drive and 128 megs of RAM. So this is obviously a very off-the-shelf type thing. Nothing particularly fancy. And so the hard drive is probably mounted underneath a floppy drive. I just downgraded OBS to see if that issue is going to go away, but that issue is not going away, so we're dealing with a frozen camera. Still, I'm going to have to keep downgrading versions until we come back to one which doesn't have the stupid freezing issue. Like, I have nothing wrong with my fancy expensive capture card there. It's literally just OBS being a bitch. Robin Vandenide says, it's all about the Pentiums. Very good reference. Joshua Hutton asks, what is a PLC? That's a programmable logic controller. And they can come in, like, it's the type of thing that controls industrial machines. They can come in all kinds of flavors, from very basic things which don't even have a display, which you just program with some special software, to things like this, which is literally just a Windows PC running a piece of special software. And the flop, it does not want to let go of its floppy drive. There we go. So that's the hard drive out. Let's put that in a safe space where I don't have any magnets. Do I have magnets on that shelf? I do not. Okay, first things first, we have a CR2032. Let's just check that. I wouldn't expect that to cause black stripes. And it seems to be completely dead. we have, I believe, no clock battery in this, because that seems like a reliable ground. 0.03 volts in that, so that's going to get replaced as a matter of course, and the customer is going to be happy to get his clock back. But the interesting part is, of course, going to be why there are black bars on the display, which is the main concern here. So I'm going to fetch a power cord, and we're going to power this thing up. Here comes with a genuine Apple iMac G4 power cord, I think. These are the best power cords I have ever owned. I own two, and I will cry the day they break. They're so nice and soft and flexible. I don't imagine this thing is going to flash any particularly sensitive information on screen when we power it up, but I'm going to keep it to myself. Just in case it's customized for the company. Power on, and we have a main switch down here somewhere. Click. We have fan spin. Sadly, that does not guarantee function in our world. And it's starting with a completely normal outward bias. And it's looking absolutely fine. So this is of course part of the course. It was sometimes it would work just fine, other times it would not work. So this is where I wish I had my rear camera, but alas, we do not. So I'm just gonna basically poke around, see if we can find the display wire. Where is the actual display cable? It's going to be way down there. How annoying. We don't just have bad power supply connector. Wiggle wiggle. We don't seem to have bad caps on the main board, even though this is kind of a right generation of device to have bad caps on the main board. This fan is not particularly happy. It's spent quite a few hours in its life. Now we actually have a power button, which does not turn off a fan. It just power cycles the monitor. So power cycling the monitor does not seem to cause the issue to come and go. It seems, yeah, it's also power cycling the backlight. So by doing this, we're actually causing a bit of a surge on the power supply rails. And if the issue was caused by ripple and noise on the power supply, this is sometimes a decent way of just making the issue appear, but it doesn't seem to be related to that. We also have brightness increase decrease buttons, which seem to do nothing at all. Oh no, it does decrease with brightness. Just very barely noticeable. I can hear that the fan actually spins slower with a backlight on. So we do have some voltage droop out of the power supply. I didn't see any obviously bad caps on a power supply. It has been reworked. I can see some replacement caps in there which you wouldn't have shipped with it. So the power supply has been worked on before, the inverter has been worked on before. So I think it's time we just rip further into this. So for those who weren't here just when I started the stream, this is a PLC which has an issue where it will sometimes have black stripes on the display when powering on, and if you smack it, the stripes will go away. So it's most probably got a bad panel LVDS connector, or rather just a bad connection in the connector, which is going to be good. So we're probably on a mission to just rip this thing into molecules and put 1 milliliter of alcohol into one connector and then charge the customer a bunch of money. Anyone aspiring to become an industrial like tech, this sort of work is pretty much the majority of what you'll be doing. You get things which kind of work-ish, and then you prod and poke at them, and then they start working again. Some people try to make this job way more professional than it is. Like a huge part of what I do is just fuzzing. And if you're not aware with hacker terminology, fuzzing is when you just kind of prod and poke around and bend and twist and feed random data into things until something happens. And in cases like this thing, where it seems to be working fine, but if it was working fine, the customer wouldn't have given it to us. We need to figure out what causes the issue, and you can't make some really smart, good, systematic approach for that. Like, you're not going to be able to figure out what every single RC in this thing does and mess around with it and read data sheets and figure out what's wrong. You're going to have to poke and prod and try ripping wires out and see what happens and just experiment. That's something I was very afraid to do when I was just starting out. Like, the idea of not doing stuff by the books was terrifying. But after a few years, you realize there are no books. You can't do everything as they teach you in school, because the school doesn't teach you how to do this. What do we have? Okay, so this separates the... this is really annoying. It separates the entire monitor assembly from the frame. And then we'll have screws from the other side. It's the second most annoying model of a touchscreen controller or touchscreen PC layout. The previous tech has already made an X for us to line it back up, which is good. Saves us the time. Some of these will actually have the touchscreen mounted to a piece of acrylic that's mounted to the front plate, and you'll have this like horrible plastic wire that you need to undo in order to get the touchscreen to separate from the actual monitor, and those are just completely horrible to work with because that wire is not fun. Rose Electronics is showing up in chat asking how I'm doing. I'm doing just fine. Just fine, man. And then they ask what does FF stand for. That's a mystery that I do not really give an answer to. You'll have to use your imagination or ask someone in the know. Is there really an answer to the question? I won't tell you. It's a mystery. Rest assured, there are many, many theories for what FF might stand for. Many, many theories. Right, one more screw, and then we'll see just how far this thing is going to collapse. Two more screws. Sometimes the touchscreens also go flying, which is never fun. Let's... Oh no, it's rather obvious. We have a cutout for the wire there, so we don't need to mark out which way that goes on. So this touchscreen is not going flying, which is good. And now we have 4 more screws to get the actual panel assembly out. Now then maybe we can actually start to messing around with the wiring. So we are going to have to power this thing on while messing with it, so that's coming up shortly. I don't want to power it on yet, even though we are about to manipulate the wire going to a display. Oh no, this is just the touchscreen. This is horrible. I hate these where the touchscreen comes off, because they're usually basically impossible to disconnect. Oh, hang on. Am I being an idiot? I am being an idiot. I am being an idiot. We don't need to get the touchscreen off, I think. Let's just bolt that back on. Let's just bolt that back on, get it somewhat lined up. Like you generally never want to separate the touchscreen, unless you have to, because they are just so finicky and annoying to work with, and you will, without exception, get a bunch of dust and crap between the touchscreen and the display, which is not, it's not a huge deal, but it's annoying. You don't want to give customers dust inside the displays. Also a huge issue if you're doing like backlights on TVs, you just get them full of dust and crap, and then people get annoyed with you. Okay, let's disassemble this in the proper way, which is like this. What wires do we have? Okay. Good, I can see. We basically just have one big panel wire going to all of this. So now we can power this thing up and mess around with the wiring and see if we can get it to do bad things. No. The plastic cover for the replacement caps came off. Let's see. We had something funny going on there. I don't know if you caught on to it, but there was a line all the way down. Let's see if we can get it worse. Oh man, there was definitely a line on the screen. Yeah, there's a line there for a moment, then it goes away. Huh. That's interesting. David Blastrom says, hey, haven't caught a stream in a while. There haven't been many streams to catch. Ah, it's getting worse. So now we actually have a symptom on this thing. Oh. Look at that, I'm bending it. Ooh, this is looking bad. That's not what we want to see. Now the question is this due to some internal fault in the panel? I think it might be. Or is it due to some interconnect messing up? Now I'm messing with the panel wire going from the PC to the panel. Now that does nothing, but if I bend on the actual panel, even just slightly, it will return. So we have a panel failure on our hands, which is not good. But it could be a whole lot worse, because these old panels are relatively easy to work with. But now we actually have a symptom, which is much more than we had. Hey, there's a black bar, as the customer was describing. We actually have a symptom to work with now, which is good. So we're going to have to see if we can replace the panel, or if we can repair the bonding wire, probably over there. Ah, I just made a mess. So we're going to have to rip the panel assembly out, which is very easy. Literally one wire. That's a nice design. Sadly, it's not the wire that's the issue. So we can actually put the entire PC aside now, while we investigate. And we need to put something nice and soft down here so we don't ruin the touchscreen. It's not super happy to get laid down like that, but it's happy enough. That's better. So we have LVDS here. What's actually what? So this is the touchscreen wire. This is that thing I was talking about. That's often horrifying. Where is the actual LVDS to the panel going? Is it going from straight underneath this board? No. It must be going through that connector there. Of course, it's underneath the touchscreen wire. So what we have, it is possible for this connector to actually cause problems like this, and there's a connector on the underside of this board as well, which could in theory cause these problems. So let's just take this out, put some isopropyl alcohol on them, and hope for the best if they would come out. I don't want to take the panel apart unless I really have to. there's that end out, and it's going to be underside of that board, so we have to unbolt it. I don't think this cable is going to be the problem. It's very unlikely, but I want to try it just in case. There's the other end of that connector. These are a bit annoying to get out. They're so thin and flimsy that they just want to bend and break. There we go. A bit of booze on that. I want to check the solder joints as well, because it's actually somewhat common. I've seen it happen a few times. That these connectors just kind of fall off a board, because it's a very large connector given the surface area of its solder joints. And since they're surface mount and mounted in the way they are, there's usually a decent amount of just pull straight up on the solder joints, which tends to make them want to just cease being solder joints. Again, we are probably barking up the wrong tree. Why are you not going in? Did I bend a pin in that guy? Did I bend a pin? I think I bent a pin. How the hell has that happened? There are two very funky looking pins in that connector. I cannot for the life of me see how I would have caused that just now. Must have put it in just ever so slightly not straight. Okay, let's try again, see if that'll fit. There we go. There we go. No more bent pins. So let's just bolt these boards back in place and do the bendy thing on the panel again. See if the problem persists. I'm going to say there's an 80% chance that the problem persists, because the nature of the issue just looks completely like an internal panel fault, or rather a bonding wire fault between the driver PCB of the actual LCD and the glass. David Blastrom very correctly points out flex on top of a panel much more likely. I absolutely agree, but I want to just try, because it's a very quick test. And something I have learned is to just do the easy thing first. If you can do a fast gamble, it's going to be worth it, because we're going to have put 10 minutes into doing this cleanup, and hey, it could maybe work. If it doesn't, we've still cleaned the connector that's prone to going bad anyway. There we go. So, again, very big chance that it's going to behave exactly the same way now. And it is. I can bend it and cause it to flip out. So, yeah, completely as expected. No improvement. So we're going to be ripping the panel apart. Completely expected. So how does the panel actually come out? We need to get the stupid, annoying, horrible touchscreen off, which hurts my soul. Come on. Off you come. I just now realised that we didn't actually look at the connectors for that, but the solder joints for that, but meh. It's not going to be that. I'm sure. This is a bonding failure, and I'm sure we're going to be able to fix it by just probably putting like a piece of paper between the panel and the metal frame of a panel to just squeeze the connector in place. Some people like to try and reflow them. That tends to work just fine for about 6 months, then the thing comes back. Whereas if you put a physical pressure on the bonding wire, it tends to just work until the customer doesn't like the device anymore. Rose Electronics says FF equals Fluffy Floof in response to Fluffy Floof in the chat. Maybe we are the same person, I don't know. And Fluffy Floof says, for fuck's sake. Yeah. So this is going to be annoying to get off, because there's a tiny little gap and a rather fat piece of shrink wrap to get through it. And these touchscreen wires are just so incredibly fragile. There we go, and I'm going to put this way over here where it's not going to get smashed or dirty. So here's our display. Very standard, generic looking 15-inch industrial model. Fluffy Floof asks, does it come from high vibration environment? Maybe shimming and padding helps. Yeah, shimming and padding, that's pretty much what we're going to do. This thing is from some kind of metal working device. I don't actually know what it is, the customer just brought it in. Now we need to undo the backlight as well, which is super annoying on this model for no good reason. There's a huge metal thing in the way. I should have seen that before we unbolted the panel. There's the weird metal plate out of the way, and then we can undo the other backlight wire, which is rated in a horrible way around a plastic thing which we cannot undo without destroying it, so we're just going to destroy it. That's fine. Now this should lift out. And we rather obviously need to undo the LVDS, or it's never coming out. Fluffy Floofer denies being the same person as me. Nice try, me. There we go. And there's our actual panel. LVDS input board, and I can see PCB underneath here, so we probably have this PCB along two edges. Is this a passive panel? It can't be. We're going to have to start by undoing this stuff. There's that off. And we're going to need an absolutely tiny screwdriver for that. So this is looking like a rather old-timey industrial panel. Sadly, that means that it's not one of the standard 15-inch panels, so replacing it is not just as easy as taking apart the first computer monitor you find and throwing the panel in there. Ooh man, this is annoying. This is super annoying. How does this connector work? And how does this work? So if that's soldered, that's most likely not our problem. But how the hell that connects to the board underneath, it feels like a connector. It feels like a connector, but I'm really not sure. I do not want to ruin this. Is it a connector or is it not a connector? I have no idea. This is really difficult to see. It looks like a connector. It looks like a connector which might have bad solder joints. Let's rip it apart and have a look. There we go. So with solder joints on that flex looked really wonky. really, really wonky. Let's have a really close look at them. Give you guys some more brightness. Upon closer inspection, they do look actually fine on that side and on this side. I would say that this actually looks okay. Yeah, that's not our issue. That's not our issue. So this board, very unlikely to be our issue. It's going to be on the horizontal board there. Bonding wire failure. And this comes apart how? We have bendy metal bits along the edges, so I imagine if we unbend the bendy bits, it's going to come flying apart. How many bendy bits do we have? Is it just 3? I think it's just 3. And we have a couple of screws which are holding the backlight in, which we do need to undo, and probably remove the backlight as well. So this seems to be one of these quick swap backlight things where you can just rip these out. We're not going to do that unless we need to, because they're actually working fine. I don't think we need to remove the backlight for this. And I think the front metal bezel comes off now. Hopefully the front comes off rather than the back, because we want to access the front to see the bonding wires for the actual LCD. This is so much easier to do on standard like computer LCDs, because you have the hatch at the top of the screen. Oh, I missed a bendy bit. No wonder why it's not coming out. We have 4 bendy bits, not 3. There we go. Granen says the top left camera is frozen. I know, because OBS is a piece of crap. Is it that one? No. It's going to be that one. No. It's going to be that one. There we go. Now we don't have to look at it anymore. The latest version of OBS just broke support for Blackmagic devices, and I am just slowly moving backwards in time, one version at a time, until I find one which isn't broken anymore. But it breaks after like 20 minutes. So it's really annoying to try and find a new version, because you have to install it, wait 20 minutes while the application is actually doing something, and then try again. Which in practice means we can only go backwards one OBS version per live stream, and deal with broken cameras until then. Okay. This is starting to come apart. Let's see if we need to actually access the bottom side as well. I think so. We do not. Oh no. How is this supposed to work? think this really is intended to like fold up and lift off. No, I can see the PCB seems to be attached to the front metal somehow. Or is that just some tape? It might just be some tape. There we go. That's what we want to see. So, if we swap to the microscope camera, which we can't do because I'm in the wrong thing, there we go. Our problem is most likely some of these joints. Are they solder joints? Those are actual solder joints, I think. They definitely are. That's surprising. These panels are usually glued. Now that makes everything a whole lot more interesting. Because we can actually reflow these and it will probably work. I don't remember in which end we had the biggest issue. Now, this thing is so large that I can't really reach everywhere with a microscope. Now, this actually looks kind of wonky. Let's have a prod around with a blade. If I have one that's actually sharp. Oh, look at that. That's completely broken. That's interesting. That's very interesting. So, let me just get that in frame. That should be right in the middle there. Yeah, that's moving. So that's our issue. It's not a bonding issue, it's that the interconnects just break. And there seems to be a bit left on all of them. Maybe we can just solder those back in place. That would be good. It would be very good if we can just solder those in place. Interesting. That would be a much nicer solution than just putting some pressure on it. It also depends on how close to the actual panel they are broken. And it's way too close because we can actually lift that entire thing. That's not good. That's extremely not good. No fun. Maybe we're actually better off putting pressure on anyway. It kind of depends on how far into the substrate here that the solder joint goes. If the solder joint goes like all the way up there, we're fine, but we can see that it's not going to go further than that of a board. Oh, that's a pickle. That's a pickle. Fluffy flue flasks due to thermal cycling, what do you think? Probably thermal cycling or vibration. This is really not what I was hoping to see. Now the question is, do we try to solder that? I can feel that it's incredibly fragile. It will not be happy to get soldered. Or do we just put some kind of spacer in here so it'll press up against the solder joint? It's basically impossible to know how well even the grind joint there is broken. Like that big guy. Even that will lift up. That's something we can reasonably solder back down. But I kind of want to take a look in between there and see if there's actually any space between the substrate and the PCB where we can solder it. I'm just going to lift a corner up ever so slightly. Yeah, there's basically no way to solder that properly. Well, we can adhere to the very edge where it's broken off, because it's relatively thick copper, so we can actually solder onto the edge. It's thick and wide, so it's not impossible to make a reasonable joint just at the edge where it's snapped off. But it's going to be tricky, for sure. Let's just give it a go, trying to solder the big grind pad thing first. Tiny bit of flux on there. This is going to be very interesting. That did solder just fine. Is that soldered down now, or is it... No, it's soldered down, not just stuck with flux. So we can probably do the same thing on all of these. They are probably all going to have roughly the same issue. I don't need a microscope to do those. So by doing the ground ones, we can kind of prod down the ones which haven't failed yet, and hopefully it's going to buy them some lifetime without having to redo all the tiny ones. It's not just solder faults, so redoing it with hot air is just not really going to do anything, because all the solder's there and fine. It's just not attaching to anything because the copper traces have broken. There we go. That's all of those. Tiago Guimarães says, "Hey FFcossag, greetings from Portugal." Greetings indeed. The second camera feed is stuck. I know. It's OBS's fault, not mine. So, now we have resoldered all the grind lugs. Now the question is, can we actually do anything about the actual failed joints? Let's get just the tiniest bit of flux on there and give a few of them a go. I'm not sure if we're going to need extra solder or not. It actually does stick down a bit. Yeah, we will need a bit of extra solder though. I can feel that it's not really taking as well as I want it to. DJ Shady asks, vodka? No, no vodka. We're at work. This is not vodka time. This is annoying to work with. Some boards and some solders just want to make a mess, and this is the type that wants to make a mess. So I think we're going to really have to make do without any extra solder. Only a bunch of extra flux. A bunch of extra flux. I do have like a vodka bottle for water to the soldering station just because these vodka bottles are amazing to pour out of. They never make a mess. So that's why I have a vodka bottle. It's just the best bottle I own. I think we want to go to a blade instead of a tweezers. Because we need something sharp to poke this down with. It's pretty much impossible to really see what's going on. I have no idea if this is actually working. We're pretty much just praying that the flux does its thing. I'm starting out of the end of a solder joint because there's a tiny bit of excess solder there, and I'm pulling that solder in towards the panel where we need to be making the solder joint. Oof, I can just feel how some of these don't really want to go. Yeah, that one's just not going. It needs extra solder, and adding extra solder makes a mess. Like that. Did that work? Kind of. I really don't trust the original solder to do a good job here. Someone's asking what brand of flux I use. I'm using SRA. I think it's TF5000. It's the one they have at PCBsoldering.co.uk. It's fine. Actually, I want to redo this entire row and just pull some extra solder onto it, because I don't trust the solder joints with the original flux, with the original solder. Oh, there was a piece of panel wiring that was just free floating around because it had to let go completely. Now it's starting to look a bit better. I'm getting the hang of this particular board. It gets really mad at me if I actually touch the soldering iron to the board. It just wants the floating blob of solder to do its thing. But if I'm using only the floating blob of solder, it seems to be doing a good job actually getting resoldered. I put way too much solder on the tip there, so it's going to make a mess. Come on, get the final few. Beautiful. I have one double joint there which I need to wick up, but all in all that went pretty well. And the focus on this stupid microscope camera is terrible. I think this is going to do a reasonable job, even though I don't like it. And we need to do pretty much all of these, so we have another like 5 to go. Because they're all going. Drudge work. But let's see how quickly we can do it. The process is going to speed up the further we go along. I think I'll use the slightly larger solder this time too, just to get a bit more to work with, because we're doing as much of the entire length on this one. No, this focus, it's so bad. Okay, I'm going to try and fix the focus for you. So it's in good focus for me. That's about as good as it gets. And it's out of focus again. The focus on the camera doesn't seem to track really perfectly with the focus of the microscope, which is annoying. But I guess you have to just deal with it, because I can't spend all day messing with a focus, sorry. Oh, come on. It's really tricky to get it to actually conduct heat into the upcoming pads, which is required to get the blob of solder to move on. We need to get a bit of fresh flux on there because that's just turned into a brain mess. Come on. Good enough. Come on. Free bridged on this one, but that's fine. There we go. This is so ugly. Not my soldering work, but the way these wires have snapped, it just makes them almost impossible to solder. And it's just, it's not producing good quality joints because there's no possible way of producing good quality joints here. I we still have a stupid crashed camera on this one. Oops. So that's 2 out of 1, 2, 3, 4, 5, 6, 7, 8. 2 out of 8. The further to the center we get, the better they look. This bloody focus. It's triggering me. We're definitely picking up speed because that was an entire one, which is good. Gotta go fast. Green Hills Zone music intensifies. And let's check this one. It likes to make little bridges right where it goes from the PCB to the panel flex. There's one. And now it's no more. Good. That's number 3. Unbiased says, we lost camera 2. You lost camera 2 right as the stream started because OBS is an idiot and it crashes if you're using 2 Blackmagic capture cards at once. So that camera is just frozen and I have taken it off so that no one's going to keep telling me that it's frozen, because I know it's frozen because OBS is annoying. That's our flux. Fluffy Floofer asks, do you have to put a little PB sticker on things when you fix them with leaded solder? I don't care. The amount of lead that's in a couple of solder joints is marginal. There's probably more contaminants in like the raw materials in the ROHS product to begin with than the lead in these like minuscule solder joints. Come on. Come on, blob, move on. That's number 4. We're halfway there. And check for bridges, because there's going to be at least one. Yeah, that's good. Now we're on the last half. Would you believe it? So when we're done with this, I want to test it, and then I want to just kind of fill this area up with glue to just mechanically reinforce it and make sure this issue doesn't reappear. Because if we just resolder these and put it back in service, this problem will come back sooner rather than later. Because we're just treating the symptom right now, we're not treating the cause. That said, the symptom does need treatment. We can't get away from that, but we also need to treat the cause. That's number 5 out of 8. Check for shorts. Oh, wow, not a single short on that one. Beautiful. Dave Days says, looking good by the way, nice work. Thank you, Dave. What do we have here? Now we just have a bunch of flux residue on this one. It looked like water ingress for a second, but it's flux residue. So we're getting a bit of free flux on this one. Grimson says, hello from Poland. Hello, Polish person. I hope you're having a nice Polish evening. Yeah, my behind is itching and it's annoying. Okay, I need to deal with that. Gah. So, to reiterate, I'm pretty much always holding the soldering iron above the pads. I'm not really touching anything. I'm allowing the big glob of solder I'm pulling along with me to do all the thermal transfer. Because if I poke down hard, I just want to rip everything apart. These broken little solder things that are pretty much just lying around here are very, very delicate. They want nothing more than to just go floating away and crossing over as many of the other solder joints as they possibly can. I think we might have quite a few shorts on this one. So let's do a rather thorough inspection of it. It felt as if it was making shorts. Oh yeah, there we go. There's a short there, I can see you. Or is it just a reflection? No, it is definitely a tiny, tiny short. A very small short. There we go. I had to add a bit of extra solder to just kind of push a blob into the short, because the short was almost underneath the plastic flat flex thing. So I couldn't actually reach it with a soldering iron alone. There is another one. Now that's fixed. There's a piece of loose solder embedded in flux. I'll just ignore that. Looking fine. Only 2 more to go. Oh, this seems a bit worse for wear. It was kind of poking up in the corner, and we want it to be really snugly down against the board. Come on. This one is a little more oxidized than the other ones for some reason. This is not going well. This one does not want to do it. I think I'm going to grab some fresh solder because that just took way too long. It's starting to kind of oxidize. I think we made like 1,000,000 bridges over here. Yes, we did. Ugh, super annoying. Lieutenant Lynn-Buck Compton says hello from France. Hello, France. Come on. A little bit of oxidation on this really makes it a lot harder to work with. This one is just impossible compared to the last one. Okay, we've fixed all the bridges there, finally. Now we just have the rest of this oxidized mess to go through. It doesn't want to do it. It's just making so many bridges. I have no idea why this one is so oxidized. None of the other ones were. It almost looks as if they've left a bunch of unsoldered solder paste on it, and that's caused some chemical reaction over time. I guess we're just using more flux. So many bridges. This one's going to take forever to clean up. Okay, well there's the end of it, but we have a lot of cleanup to do on this one. It's completely full of micro shorts. Hoo boy. Andrew Joy says, not enough flux, I can still see the PCB. I wish. I wish it would just not enough flux. There are 2 more shorts. 1 fixed, 1 made significantly worse. And now we have 3 shorts. There's too much solder there, we need to wick some of it up. There's still a short there. Now there may or may not still be a short. I don't like the way that looks. We need more flux, and we need to sadly add a bit more solder back there. Where are we? Is this one I'm going for? Yes. Like so, and we'll wick up the excess, and hopefully that's going to be fine. Yes. Good. Moving on, there's going to be probably more shorts. Those guys look shorted. Yes, they are. And they are fixed. There are 2 more shorts. There's my solder line. 1 fixed, 2 fixed. And that's it, and let's do a check in the other direction just to be completely sure, since this one was so difficult. Now this area is so overworked. This one has a hint of a short, so we're gonna clean it up. You can just barely make it out between the pads on that one. That's my solder. Yep, it is shorted. And we wicked that up beautifully. And the short is gone. Okay, that's fixed. Phew, that one was terrible, and we have one more to go. Hopefully. Oh, it's just as bad. This one looks just as bad as the last one. And what's worse, we've obviously got failures on it. You can see how the board is pulling up here. That's not what I wanted to see. Annoying. So we're expecting another 10 minutes of just cleaning solder joints. Ten minutes of cleaning solder joints. Going very slowly to allow the flux to really do its thing seems to help. But then the flux gets heated by the radiance of the soldering iron and goes away, which is annoying. Come on, move on. Our blob has grown too much in size. No, don't make bridges over there. Ah. There is going to be so much cleanup on this. So much cleanup. So many micro shorts. Okay, so now we've done the first pass, and this is just going to take forever to actually finalize on the maximum magnification. So there I intentionally made a big short, because big shorts are easier to deal with than small shorts. That's how easy they are to remove, but now we have small shorts coming up. That one went well. That one went well. Hey, that's 3 in a row. Come on. We need to wick a bit there. There we go. Well, that's not helping. Here's a bunch of shorts. Wick, wick, wick. Okay. Man, these are dodgy. And we need to do one more check on this. I think we got all of them, but I need to be sure. Dave is asking, what's the PLC controller doing? I'm not entirely sure. I think it's some kind of metal working machine. That's a short still. Ugh. Whatever it does, it's very important, because apparently the customer is just not getting anything done while it's out of commission. That's suspicious. Tum 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 tum. Tididum. But we found the imposter. Okay. I think that's finally it. We have resoldered all of the panel strips. That's annoying. Ah, my poor neck. So, what we've just done is resoldered all of those. Hopefully we haven't damaged anything. There's always a risk when dealing with these things that we're just going to have a giant stripe going that way when we pair it on. There's no way of knowing. We've done our best, but it's time for a test. I'm going to ignore these guys. Let's just pray to higher powers that they're okay. So we need to reinstall the input boards, both of them. Robin Vandenard says, smoke test. good old UXW Bill. A YouTube nerd legend. Now I'm just going to put like one screw in this whole big board. Am I using the wrong screw for this? Are there several different types of tiny screw? I don't think so. I'm going to assume that they're just not very well threaded holes. Ah, this is horrible. I can feel it falling into the start of a thread, and it's just not wanting to go in. Oh well. I guess instead of one properly tightened screw, we're putting in two improperly tightened screws. Oh, that one threaded in just fine. There we go. Oh man, I really actually want to tighten that one down because it's right by the LVDS connector. Brute force worked wonders. Okay, and there's our LVDS board, which goes in some direction. I think it was this way. That fits. And now we just need the rest of the panel assembly. Or rather, we just need the PC. No, we need the rest of the panel assembly. Because that's where all our wiring is. Now this panel is actually not held in by anything, so we need to be rather careful. And because it could, if we put this upside down, the panel is just going to go flop. And that's not gonna make our dodgy solder joints any better. The panel is probably going to be fine if it falls out of the frame, but our solder joints are just not going to be a thing anymore. So very important now to just keep this straight. And a PC. And an LVDS cable which we are connecting. There we go. And we need a backlight. One backlight. And I'm almost tipping the panel out because I'm a jackass. 2 backlights. Okay, that should be enough to get this thing to display something. Okay. That should light up. If and only if we have not ruined this. Watch one of these driver chips just go on fire. Here we go. And it's not auto powering on. Well, that's annoying. That means I need to get this stupid power button in place. And that goes like somewhere. Here. That's annoying. Okay, we are not going to be cutting the lead off of a power button. That would be a bad move. Okay, now we have a power button-ish. Let's try it again. And it's not powering on, so we must have missed something, or everything is shorted out now. What would be preventing this thing from powering on? It does not power on if we disconnect everything. Come on. Why does it require the touchscreen to work? That would be annoying. It probably does require the touchscreen to work because I think the power button also goes on the touchscreen controller. And let's make sure of that first. No, the power button's not going to have a touchscreen controller. Oh, I have put one connector in the wrong place. Let's hope we haven't ruined everything now. Oh, that's terrible. They're using a connector which is... There's a 4-pin and a 5-pin of a panel, and the 4-pin fits in the 5-pin, but in the wrong place. Let's hope nothing broke because of that. Let's very much hope nothing broke because of that. This could be the start of a bad day. Hey, there we go. That was risky. I got very nervous there for a second, but let's mess with the connectors and see if it's better or worse. That Q-tip is just falling apart because it's sticking to the flux. Let's cut it off. So the issue was obviously caused by these guys flexing and making intermittent connections. This is looking very, very good. Let's undo these screws and flex the panel a bit. Poke it with a stick. This isn't the EV vlog. I'm bending it considerably. And nothing is going bad. This is looking very good. This is more bending than it was experiencing before. Considerably more. Okay, I'm gonna call that a fix. Asterisk. Partial fix, because we still need to fixate this so it doesn't happen again. Rose Electronics asks, still going strong? Yes, we just we have fixed the first issue with this, which is the broken solder joints. Now we need to fix the cause of issue, which is that the panel is too mobile. The panel moves in relation to the PCB. So I'm gonna take the panel back out. We're gonna clean up the flux. And then we're going to put some plastic glue in there to make sure it doesn't get a chance to move in the future. This is also going to make it completely unrepairable in the future, but I think that's a better solution than doing this once every 5 years. It wouldn't last 5 years, it would last a few months if we didn't do anything to fixate everything. And before we do that, I'm going to take a 2-minute break because I need to go to the bathroom, so I'll be back in a moment. There we go. We are back. Nice and relieved. So what we're going to do now is just clean the flux off of the connectors there and put some glue on there. So if you're just joining us, we have just pretty much fixed this thing. The issue was that there were intermittent stripes in the display, and by spending a ridiculous amount of time reflowing several hundred solder joints, there are no longer intermittent stripes in the display. So we had vertical stripes going like that in random places, and we resoldered all of these, which actually soldered rather than glued on this, which is nice-ish. So now we're going to clean it up and fixate everything so the issue doesn't have a chance to happen again. We're going to need to use 1 million Q-tips and about a litre of alcohol, just because there's so much flux residue here. All the exciting parts of a job. The glue I'm going to be using is a plastic-based, it's a Casco brand. You're going to see it in a moment, it's very good. It's one of these rather modern plastic glues which are based on a catalytic reaction rather than off-gassing something to cure, and they are just excellent for this kind of thing where they're pretty constrained. They don't really have access to much atmosphere. So many traditional off-gassing glues would just not really cure properly if you make like a giant wide seal with them. But these new plastic glues, they will cure properly, which is nice. How it works is, I have no idea, but it's basically magic. I'm using a very light hand on these because these solder joints are not going to be very strong. Even though they're reworked properly, there's just not enough area of the conductors left to make good, strong solder joints. Fluffy Floofer asks, but it's not epoxy / 2-pack / 2-component? No, it's not. It's a single component, comes in a tube. It's commonly used as like mounting glue. Here it's usually white in color. The stuff I have today is black. It's some weird magic plastic thing. It's really good. I love it. It doesn't smell anything when it cures. And it just kind of cures magically. I'm almost out of alcohol. And we are out of alcohol. So it's a refueling break. And back to work. Okay. There we go. Now, which way around does this go? I think it's asymmetrical. Yes, it is. We have 3 locks on that side. That's going to go on like so. No, it's not. It's going to go on like so. Yes, that's correct. So time for magic glue. This is the type I use. Casco Marin och Teknik. Very Swedish branding. But I'm not sure what the equivalent would be, but their website does state like the technology they use. And it's just complete magic. So I'm just going to put down a thin string there, which is going to press up against the metal frame of a panel. And that's just going to keep this mechanically in place as the years go past. Go by is the correct word for that. This is about as fun as watching paint dry, isn't it? Watching glue get applied. And it's black glue, so you can barely even see it. So I'm putting a rather tall clump of glue here so that it's going to get compressed by the metal frame when it does come down. Like so. It would be a good idea to put some tape over that in order to make it not stick to the metal case, but I'm worried that it's not going to spread out properly and provide even pressure, so but then again we don't want that to accidentally lift the glue. Yeah, we're going to put a thin strip of tape over the glue very lightly, just so that actually let's not use tape, let's use office paper, because that's a bit easier to put down. Is this 1A4 wide? Beautiful. It is exactly 1A4 wide. We'll cut a reasonable strip of this. That's actually going to be way too thin. Let's make it a bit fatter. Perfect. We do not press down on that because that's what the metal frame is for. So a bit of a paper there is going to prevent the frame from actually lifting the glue if there's some mechanical disturbance. Because lifting of the glue is exactly what we're trying to prevent. Or rather, lifting of these solder joints. Snap, crackle. Come on you go. Okay, there we go. That should now cure and maintain a very light pressure on the solder joints, hopefully stopping them from coming undone again. Come on, bendy bits. Get bent. Get bent, I say. Okay, that is one reassembled panel. Fluffersloof says paper might become conductive when it gets moist though, but it doesn't matter, the paper is not touching anything other than this metal. There's glue between the paper and the, what's the word? Contact, solder joint, chip, flex things. It's actually connecting to, so it doesn't matter. This thing clearly has not been used in a moist environment anyway. So I'm not too concerned. So back the panel goes. And yeah, we actually do need to reassemble it. And I'm going to be careful not to lay it down on its face because that's going to compress the glue in a way we do not want. We want the glue to only get compressed by the final assembly of everything. Shielding can. Now these screws are not threaded very well, I must say. Or it's just this one particular screw that's a piece of crap. Let's just use the other one. Oh. The board is supposed to be mounted with one screw through the actual board. Like so. The rest go through the shielding can. Lofair says, hey there, hello. You have missed all the super exciting redoing millions of solder joints which are all identical action. In other words, nothing. You are right now watching the reassembly of like a PLC type thing. Super exciting PLC reassembly action. With extra care going into not squeezing the panel because we've installed some glue to squeeze the flat flexes which go to the panel because they had bad solder joints. Okay, I think that's going to be most... oh no, we have 2 more screws for this, I think. Maybe, I don't remember. That looks like a screw hole. Is it a screw hole? It feels like a screw hole. It is a screw hole, but I'm using the wrong screw, I think. I have completely forgotten how these screws are supposed to go in, but oh well. This one just feels way too long for this. I really do not want to just ram a screw through the panel. That would be bad. Oh well. Yeah, let's just say it's correct. The panel shouldn't reach this far out to the edge anyway. I know, these are the backlight. Wait. We have 4 identical screws. I know where 2 of them are supposed to go, but I don't I know where 3 of them are supposed to go. I don't remember where the 4th one is supposed to go. Oh no, they go through the board, I think. Yes, they do. So I put one... oh, okay. I figured this out. I have put one screw in the wrong place because they use a really weird and confusing mounting system for the signal input board. Now we are on the correct page. Okay, this one goes in there. There's a couple of really long screws which go through these humps here and then thread directly into the panel to hold the signal input board in place. And that just completely confused me for a moment. And then we have another couple which hold the backlight tubes in place. One backlight tube. Two backlight tube. Fluffy Floof says he has a 114 BPM pulse. That's concerning considering you're just sitting around watching a stream. This isn't that exciting, you know. bendy bits go bend. And okay, this should now be able to mount back into the frame. Beautiful off-screen action. Like so. And we bob that down. Now then it's time for the touchscreen. Don't be like that. Okay, Fluffy Floof, just take it easy there. Just take it easy. You're going to be out of lockdown. You're going to be getting to go to the karaoke bar soon enough. Just take it easy. Right, I have accidentally spat on that, so we're going to give it a tiny wipe so it doesn't have any unnecessary dirt in it. Okay, that's actually not spit. That's from the manufacturer of the panel. Not my fault, so we don't care. Right, touchscreen. Oh, how these are dreadful. In you go. Pop. That could have gone worse. Robin van der Nod says, next we'll try to bring up this very stream of a Pentium 2. Please, it's actually a Pentium 3 Celeron 566. We have over 0.5 gigahertz of raw processing power. I mean, a 566 Celeron Pentium 3 could probably decode the 360p stream of this just fine. Do not underestimate the power of a Pentium 3. Right, well, that's the touchscreen. Now we have a bit of housekeeping back here. Panel input board goes on there with its two ridiculously long screws. the touchscreen thingamajig goes somewhere, like so. And we need to be proper and put the zip tie back as well. Beautiful. And we finally have the power button, which we shall not forget. And the backlight. Backlight goes before the power button because else we can't access the backlight. There we go. Now we can put the power button back on. It's going to be these 4 screws. That should be it as far as connections back there are concerned. So now we're ready to put it back in the PC. There's a connector here that I just want to, or rather a wire that I just want to twist around something so it's not flopping around too much. There we go. Plop. There was something funny about the screws for this. I think it went into... things which want to go flying. I think the screws went into this, which had an X. And this went on like so. And then the screws go through that. And now it's time for the exciting screwing action. The part you've all been waiting for. 1 million tiny screws going into tiny tight holes. Oh yes. If they actually line up, that is. Old technician's trick, always put all the screws in before you tighten a single one. Else you're going to have one hole that's kind of ever so slightly out of tolerance, and you're going to have to untighten every single screw to get the final one in. Robin Vandenite says, oh, it's getting screwed up now. Oh, yes. This thing isn't as bad as Hatteland radar monitors. To get into a Hatteland radar monitor, you need to undo, I am not joking, about 100 screws. Because they're just stitched together so tight, it's ridiculous. I have no idea why they do it like that, it's just bad. But when you're paying like 20,000 euros for a Hatteland radar monitor, I suppose, you would expect to get screwed, eh? Narrator. Right after he finished assembly, he noticed exactly one very large, brightly shining and disturbing dust particle right between the panel and the touch digitizer. His gaskets held tight. Yeah, with this sort of thing you don't care about one dust particle, to be honest. It's not a TV. It's a thing that gets manhandled by someone with so dirty gloves as to leave giant marks on it, which we are going to wipe off in a moment. Now there's some really durable crap on there. It's gonna get all messed up again, so I'm not gonna risk damaging the screen just to wipe off a bit of dirt. These resistive touchscreens are very sensitive. Okay, let's do a sanity check before we get too carried away. I want to see that it still lights up as it's supposed to. Oh, that's looking just fine. Nothing wrong there. Beautiful. So now we have the front panel, which goes on in some direction. And now we're back to screwing. The previous tech had put the broken warranty void sticker screw in the wrong place. I'm putting it back in the right place. So now we have a complete broken warranty void sticker there. If that's not dedication to quality, I don't know what is. Oh yeah, we're not going to forget to swap out the CR2032 while we're in here. And then of course hook up a PS2 keyboard and set the clock. Two more. He lied because there's a million more for the back panel. And we tighten them. I cannot be bothered. I really cannot be bothered. Wow, these screws are bad. These screws are really, really bad. Okay, that's tightened down. The screws just literally let go at torque setting 7 on this extremely anemic drill. I can probably like hold on to that and shish. That was weak. Right, so what are we missing? We're missing power supply cover, we're missing the very funny food packaging capacitor cover, which we're gonna glue back. That sure is something. And where's the floppy drive? Where? Oh yeah, the floppy drive and hard drive are up here. And part of me just wants to make a backup of this hard drive instantly, but no one's going to be paying me to do that, so I guess I'm not. CR2232 coming out. And a new one going in. Hard drive plugged in. Flop drive plugged in. Some people actually use floppies to program these things to this day, because there's just no other way of doing it. And the screws have gone underneath the microscope, but we did manage to retrieve them. Okay. Now we're just missing the CD drive and the aft fan cover. CD drive and fans which go there. Come on you go. Only 1 million more screws. And we're of course going to start it up and see what the PLC program actually says. Make sure it boots into Windows correctly. That's clearly not doing anything. Oh, come on. More screws, more hatches. This is the part where we drop one single screw into a device and it just falls into the deepest belly of a beast. Three more screws to go. 2. Two with violence. And 1. We are all out of screws. We are done screwing. So now we need a PS2 keyboard so we can actually set the time of this thing. Cue late 90s IBM media keyboard. Come on, in you go. Which Windows does this Windows sticker refer to? Windows 2000 Pro Embedded. What fell off? Ah, the food packaging cover. I cannot see anything. Ah, this is vintage, isn't it? January 1st, 2000. Now this panel actually looks like complete garbage right now. There's a bunch of rows missing. Oh well, it's legible. Let's hope it works better once we get to the Windows setup and it to get into Windows and it gets the right resolution. August 2024. I'm hoping it actually is detecting a hard drive. It's 2309. I don't imagine we need to really do anything else. Let's just say that's... oh god, that's horrible. This is not fine. This is completely horrifying. We're missing a bunch of lines. I think we missed them from the beginning. Yeah, this is bad. But now it looks fine. This is looking good enough. Let's just see what the software has to say. Well, this is really not looking too bad. It's like some PLC thing. It doesn't have to be perfect. We just need to not have giant black bars everywhere. It's definitely looking funky. But it's legible thus far. So we have weird distortion on the top bar there. Touchscreen is working. It has some weirdness, but this looks good enough. Copyright 2003. Can we get like anything? I mean, this. Come on. Ha! Something on a floppy. Give me Internet Explorer. Just to give me some text. This looks good enough. The text is perfectly legible. There's some weird color grading issue at the top. You can see how that's not the right color, and there's like weirdness going on. There's weirdness going on, but I think they're good enough. It seems to be specific spots on the screen just don't handle specific colors very well. Yeah, we don't have a password for this. I think we're gonna call this good enough. We don't have random giant bars on the screen anymore. It is now safe to turn off your computer. Goodbye. Kimi Tikkanen asks, can it run Crysis? No. At least one issue I think we've fixed is that it's not gonna be mad at us for having the clock not set anymore. So that's gonna be nice. Yeah, good. So that's going to be it. We are done for tonight. And I'm going to see you guys some other time, I suppose. Thank you for watching, the very few of you who did. Kimi Tikkanen asks, is there a Doom port for it? It runs Windows 2000. You could literally run a normal Doom on it. But yeah, I'm going to end this now. See you around.